Okay, so on to question number 5. Phosphorus pentachloride decomposes according to the chemical equation. 0.215 mole sample of phosphorus pentachloride is injected into an empty 2.5 liter reaction vessel held at 250 degrees Celsius. Calculate the concentrations of PCl5 and PCl3 at equilibrium. AC is equal to 180 at 250 degrees Celsius. Okay, so first I'm going to write the reaction down. Phosphorus pentachloride gas makes phosphorus trichloride gas plus Cl2. Let's try to make it fit. Just move everything over. Okay, so the equation is already balanced. There's 1 phosphorus on each side and 5 chlorine atoms on each side as well. So now I'm going to make actually first I will find the concentration of our reactant. So I'm going to do it down here. So they give us the number of moles of phosphorus pentachloride, which is 0.215. And they also give us the volume of the reaction vessel, which is 2.50 liters. So to find the concentration of phosphorus pentachloride, it's going to be the number of moles divided by the liters. So this gives us a concentration of 0.086 moles per liter. Okay, so now I can construct an ice table with the balanced equation that we have. So the initial concentration of our reactant is 0.086, and the initial concentrations of both of our products is 0, since we start off with 0 product. The change in the concentration of our reactant is -x, and the change in the concentration of our products is +x. So lastly, at equilibrium, it will be 0.086 minus x, and the concentrations of our products will just be equal to x. Okay, so now let's write down our Kc expression. So Kc is equal to the concentration of phosphorus it's going to be the products divided by the reactants. So phosphorus trichloride times the concentration of Cl2 divided by the concentration of PCl5. Okay, so the Kc value is 180. And if we were to plug in our x's as the concentrations, we get x squared over 0.086 minus x. Okay, so now we can rewrite this as a quadratic and if we use the quadratic equation or a quadratic formula calculator on the internet, we can get x is equal to 0.086. So you'll find two values of x. One of them will be negative and one of them will be positive. And since we can't have negative concentrations, we go with the positive value. Okay, so the last step is just to plug in x into our concentrations at equilibrium. So the concentration of our reactant at equilibrium is equal to 0.086 minus 0.086. So it's just going to be 0. And the concentration of PCl3 at equilibrium is equal to 0.086. Is also equal to the concentration of our chlorine. Okay, so let's see what the junior tutor said. The reaction given is already in a balanced form. To solve the concentration of PCl5 and PCl3 at equilibrium with the given conditions, it is helpful to use the ICE table. For initial, given that there are 0.215 moles of the sample that is injected at 2.5 liters, concentration of phosphorus tetrachloride can be computed via solving its molarity. 0.215 divided by 2.5 liters gives 0.086 moles per liter. While the concentration of the products at the initial state will be 0. For the change in concentration, let the concentration of the sample be x by the time it achieved equilibrium. Thus, to find the change in concentration of the sample will be 0.086 minus x. For the products, there will be a concentration x after the reaction. At equilibrium, concentrations of the elements present in the reaction can be related to Kc. Substitute all the values we currently have, and they got x squared plus 180 x minus 15.48 is equal to 0. Solve for the value of x using the quadratic formula, where a equals 1, b equals 180, and c is equal to minus 15.48. They got an x value of 0.085. And they just did 0.086 minus x. So they got 0.001. So when I got my x value, I just rounded up, but they rounded down. But the solution is still correct.